Hey, welcome back to the lecture, and I'm ready with my Keel project here to demonstrate the operational mode of the processor and how actually the processor switches between different operational modes during the execution of the program. Okay, so now let's get started. So I have my main.c here, and I have not added any code to that. Okay, so let me close all these other files. Okay, let me just add a simple main function. Okay, and okay, so let me add a while one loop here, and let me just return 0. Okay, and yeah, so this is a very trivial main function which doesn't do anything useful. Okay, so but let's understand how this actually executes on the hardware. Okay, so now if I just compile this code, okay, so it compiles successfully without any problem. Okay, so the statement is unreachable, that's okay, and the last line of the file ends without a new line. So there is one warning, just give enter here and save it and just compile once again. Okay, great. So now if I just download this code onto the hardware, okay, so it downloaded successfully, and let me just keep a breakpoint here. Okay, and let me just enter into the debug mode. Okay, and all right, so now the code is actually flashed onto the board. Okay, the code is not actually running now. Okay, and the execution actually stopped at this instruction. Okay, here. Okay, and this is just an infinite while loop. So you can see in the assembly the next instruction is actually branch. Okay, that is branch to this address, that is nothing but this address. So it is actually an infinite jump, isn't it? Okay, great. So in the left hand side, just open banked as well as internal section, okay, of this window here. Okay, so here you will see, observe this mode. Okay, so that means operational mode of the processor. It is mentioned as thread. Okay, so remember what I said in my discussion, processor always starts with thread mode. Okay, and all your application code will execute under thread mode. So that means this is my application, okay, a small application which actually executes under thread mode. Okay, so if I just hit run over here, the code is actually running. That means it is jumping between these addresses. Okay, but when I stop it, you can see that the mode is still in thread mode. So that means this code is happily executing in the thread mode of the processor. Okay, so now I also said that whenever the core meets with the system exception or any external interrupts, then the core will change its mode to handler mode. Okay, so now that means now we will trigger some system exceptions or any external interrupts so that we move our processor to the handler mode. Okay, so for that, okay, so let's generate or simulate some interrupts. Okay, so I'll just write a small function here. Okay, so don't worry about simulating interrupts and all for the time being. Okay, so I'll be teaching the interrupts and exception handling later in this course. Okay, so this is just to see how the mode changes when the processor meets with interrupts or any system exceptions. Okay, so I'll just write a function called generate interrupt, a small function which simulates an interrupt. Okay, so I'm not using any hardware peripherals of the microcontroller in order to issue interrupt. Okay, so I'm just simulating an interrupt, okay, which actually hits the core of the processor. Okay, so for this, so here let's simulate the watchdog interrupt. So simulate watchdog interrupt means the watchdog peripheral is actually not active, right now. Okay, I'm just simulating its interrupt. Okay, so the watchdog peripheral is not at all involved in this code. Okay, great. So I'm just taking the KIMSYS core APIs in order to activate as well as enable the interrupt. So all these things you will learn later. Okay, so before using any KIMSYS APIs, okay, so it's always better to include the MCU specific header file hash include stm32f f407xx.h in my case, because I am using stm32f407vg microcontroller. Okay, so now first I'm going to enable the IRQ related to the watchdog peripheral. Okay, so again, just watch it. Okay, so don't think too much because I have not covered this. Okay, so for this the KIMSYS APIs are available. So that starts with the name NVIC. Okay, so I'll just type NVIC, and here there are some suggestions. Okay, so I will select enable IRQ. Okay, and if you want to know the implementation of this function, it's actually a KIMSYS core API. Okay, so just select that and right click and go to definition. Okay, so here you can see that NVIC enable IRQ, and which is actually defined to this one. So let's go here, and here you can see that it takes this as an argument. Okay, so that means I have to find out what exactly is this, isn't it? So I'll just select this and right click and go to definition IRQ type, and I have to give one among these as the parameter to that function. Okay, so I will just select watchdog IRQ. Okay, I'll just copy this and I'll just come to main.c and I'll just mention here. So enable the IRQ of watchdog peripheral. Okay, so that's the meaning of this line. Okay, so enabling won't trigger any interrupt. Okay, so now we have to trigger that interrupt. So for that you have to use another KIMSYS core API, NVIC set pending IRQ. Okay, so again you have to pass this as an argument. This actually triggers the watchdog interrupt. So I'll just call this function generate interrupt from here. Okay, great, that's fine. Okay, so now when the code comes over here, it actually simulates the watchdog interrupt. Okay, and the code will then go to the watchdog interrupt handler, isn't it? So that means we have to implement the watchdog interrupt handler. So we have to implement the watchdog interrupt handler. So to know what exactly is the name of the watchdog interrupt handler, just go to your startup code and here you will see name for various interrupt handlers. So here it is, the watchdog interrupt handler. So just copy that, okay, and paste here. Okay, so this is our watchdog interrupt handler. So what we're going to do inside the interrupt handler, okay, so we'll not do anything useful. Okay, I'll just implement one for loop here. I just count, okay, from 0 to 50. Okay, and then I will come out of the IRQ handler. Okay, great. So first we come to main. Okay, so then we go to generate interrupt function, which actually simulates the watchdog interrupt. Then we'll go and trap in the watchdog interrupt handler. Okay, great. So now let's compile this code. Okay, and you can see that there are no errors. Great. So now let's download this code, and I have already kept a breakpoint here. Okay, so now let's debug this code. And okay, so now the code is actually halted here. Okay, at this instruction, it is now ready to branch to this address, that means this function, and expand this internal here, and you can see that the mode is thread. That's correct, right? The processor started with thread mode. Okay, great. So now let's Okay, remove this breakpoint and let me keep a breakpoint here, generate interrupt, because I know that the control will come now to the generate interrupt. So now let's hit run, and yes, the control came to generate interrupt. Okay, and the mode is still thread because we have not triggered any interrupt. Okay, now let's come here. Okay, and the mode is still thread, isn't it? Great. So now what I do is I'm going to pend the IRQ. That means I'm going to trigger the watchdog interrupt here. Okay, so my expectation is now the program will come to the ISR, that is interrupt service routine of the watchdog. Okay, so that means this function. So let me keep a breakpoint here, and the mode is thread. Now let's hit run and observe mode here. Great. And now when I hit run, you can see that mode is actually changed to handler mode because the processor is now met with an interrupt. Okay, and it is currently in the interrupt handler servicing that interrupt. Okay, all right, so we just proved that whenever the processor servicing the interrupt handler, okay, it will be in the handler mode. So once it finishes servicing the interrupt handler, okay, then it will again come back to the thread mode, right? So what I do is now I will keep a breakpoint here. Okay, and I will just remove this breakpoint and I will just hit run once again, and here you can see that it has come back to the while one loop which is implemented in the main. Okay, and you can see here the mode is again changed to thread mode. Okay, so great. So that's a small experiment which demonstrates switching between different modes of the processor. Okay, so your normal application code will always run in the thread mode, and whenever processor meets with any system exception or interrupts from any other peripherals, like external peripherals like your buttons or timers, ADC or any other peripherals, then the processor will immediately change its mode to handler mode, and it will service the interrupt service routine associated with that interrupt in the handler mode. And once the interrupt service routine is completed, it will come back to the thread mode to execute your application code. Okay, now in the next lecture we'll explore about the access level of the Cortex M processor. Okay, I'll see you in the next lecture.